Hello everyone, once again welcome to Genius Science Academy class. Today we are going to discuss about the atom and molecules, right? This chapter related to the 9th, 8th as well as 10th. For all the classes this is the common class. So easily you can get the idea about the atoms and the molecules. Okay, let us see what are the components come in the atoms and the molecules. First of all, we are going to see the symbols as well as the formulas. Okay, let us see what are the components. The unique symbol is used to represent an element. As we know, we use the symbols to represent the atoms and the molecules, right? Sorry for the disturbance. My mouse is not working properly today here. So we are going to see the formula or the unique symbol is used to represent each element. As we know, there are the 118 to 119 elements are present in the periodic table, and we represent every element with their symbols or with their letters, starting letters. These are the symbols we use to represent the elements. Okay, for example, hydrogen we use the H, helium we use the He, right? Like that we are going to use the symbols to represent the element. Second one is formula. Formula are used to represent the compounds, right? We use the symbols to represent, or we use the formulas to represent the what we call that compounds. For example, water is represented by the H2O, right? Like this we use a lot of the what we call that compounds are the represented by the formulas. For example, water is represented by the H2O, and a lot of the symbols we use for sulfuric acid we use the H2SO4. Like that we are use the symbols to represent the compounds. The compound means the combination of two or more elements. Remember that. It means that, let me tell you that clearly here. Sorry. Okay, let us here look. The formulas to represent the compound means here look, H2O. This is the compound. Compound means the combination of two or more elements. Two or more elements is known as the compound. Two or more elements, that is known as the compound. Here we use the symbols of elements. One is the H is the hydrogen, right? Hydrogen. Another one is the oxygen, right? OXYG, oxygen. The combination of the hydrogen and the oxygen forms the water. Water is the compound. We use the formula, like another one example we can take here, H2SO4, right? These are the combination of the element to form a compound, or we can say the formula are used to represent the compound. Let us see the second point here, that is the element symbols. Okay, the symbol is assigned to each element. The symbol is based on the name of a element. Remember that this is the important point here. The symbol is based on the name of a element and consists of a capital letter or the capital letter followed by the lowercase letters. For example, if I want to represent the hydrogen, we use the starting letter H. That is the symbol of a hydrogen. If we have to write the helium, you can observe here the helium start with H and hydrogen is also start with H. In this case, we are going to use the second letter of that element to represent it. For example, H is the capital and the E in the small letter, that is the helium, right? That is the helium. Like this, we are going to represent the element. For example, you can take the carbon here, right? Carbon. Here what we use? We use the C, capital C to here to represent the carbon. Okay, like this we are going to use their first letter in the capital letter. If the two elements start with the same letters, we are going to use the second letter in the lower case. It means the small e or small a, small h, like this, the element which have the second letter, according to that we are going to use that. Okay, next one, some symbols are based on the Latin and German name also. In the periodic table, if we see in the periodic table, there are lot of the elements we can see they start or they are represented by the German names or in the Latin names also, right? First we see here the law of chemical composition. What is the law of chemical composition? It states that, it means that the law of a chemical combination of the mass says that the mass of can neither be created nor be destroyed in a chemical reaction. Okay, this means that during a chemical reaction, the sum of the mass of the reactant and product remain unchanged. Let me tell you with a small example here. If see here, A is an element, B is also element, they form the compound A and B. If the element A having the 5 grams and if the element having B is the 5 grams of mass, remember that this is the mass. Then the product, it means the compound which is formed having the same amount of a mass. Okay, remember that it is unchanged. It means mass is remains constant, it is not changed at all. Okay, right? This is known as the law of conversion of mass. It means the mass can neither be created nor be destroyed in a chemical reaction. It means that the mass of a reactant and the product are remain unchanged. Here you can see this is A and B are the reactant and A and B is the product here. Remember that? Okay, look here, you can see here BaCl2, this is the compound, right? What do you mean by the BaCl2 here? Here, barium chloride solution, right, is ignited in the tube, hanging ignition tube in the flask by the treated with the put a fork of a flask, find the mass of the balance here. If we see the balance is remains the same when it was combined with any other compounds. It means the mass of the reactant is always remains the same when they are converted into the compound or in the product. Okay, this is the law of a conversion of a mass. Here, the lot of the scientists are given their own theory on the atoms. Lot of the scientists propose their postulates according to their thinking related to the atoms here. Here, same one scientist is here, that is John Dalton. John Dalton, his name scientist. He put the theory of atomic mass theory. He given some points here. The first point is that the matter is made up of a tiny particle called the atom. The matter means you can take anything. For example, I can take the bricks. Okay, bricks is a matter, stone is a matter, right? Magnesium, you can say, that is the element. All the matters are made up of tiny particles. Tiny particle means very small particles that are known as the atoms. Very smallest particle is known as the atom. And the second point is atom are indivisible and can't be created nor be destroyed in chemical reactions. Dalton says that the atoms are indivisible, we can't divide it further, and can't be created. They can't be created here with the man, and they can't be destroyed in chemical reaction. When these atoms are come in the chemical reaction, they are not destroyed. Third point, atom of a given element are similar in the mass and the properties. Always the atoms of a element. Remember that atom present, what we call the atom of a atoms of a given element. It means the atom of a hydrogen you can take, atom of a helium you can take, atoms of a carbon you can take, right? Atoms of a lithium you can take, right? Are always similar in mass and properties. They are not differ from these properties and the masses. And next point is atom of a different element have different masses and the properties. Dalton says that different atoms of different elements having the different masses. For example, atom of hydrogen having the different mass, right? Different mass and properties as well as properties. And helium, the atom of a helium have the different mass when we compare to the hydrogen atoms, and the properties also different from each other, right? Like next point, the atom combine in a small whole number ratio to form the compound. He tell that, or the Dalton proposes that the atom combined in the small whole numbers, like 1:1, 2:2, like the whole number, they combined with the different elements to form the compound. For example, you can take the, right, H2O. H2 is the compound where the two elements are combined with each other. For example, the atom of a 2 hydrogen here. There are 2 means there are the 2 atoms of a hydrogen present in the water and only 1 atom of oxygen is present in the water. Right? Second, next point. In a given compound, the relative number and kind of atoms are present are constant. Atoms are constant in the given compound. For example, the water. You can take the same example here. These are the constant H2. These are fixed. 2 atoms and of hydrogen, 1 atom of oxygen. These are 5 to 6 points proposed by the John Dalton, who proposed the theory of Dalton atomic theory. Right? He explained the atom. What are the components or what are the things, what are the properties, what are the chemical and the physical properties are there in the atoms. Next point. Law of constant properties. Law of constant properties says that in a chemical compound, the element are always present in a definite proportion by the mass. This is the definition here. For example, we are going to see the example here below, right? Water. The formula of water is H2O. Always contain 2 elements of hydrogen. In the water, there is always 2 atom of hydrogen and oxygen. 1 atom of oxygen. Combined together in the same ratio. For example, the ratio is here. 2:16 or 1:8 by the mass. If 9 gram of water is there, it decomposed, we get 1 gram of hydrogen. When we decompose it, we get 1 gram of hydrogen and 8 gram of oxygen. Remember, in the picture you can see here. Look here. This is the hydrogen atom. This one is the hydrogen atom and this one is the oxygen atom. They combined together to form the molecule of water. You can see here O bonds with 2 hydrogen. Right? Are you getting my point? Same here. This is the law of constant proportions. Next one is the point here, the atom. Atom is the smallest particle of an element that may or may not exist independently and retain all its chemical properties. This is a very important definition you can see here. Right. Look at the definition of an atom. You can note down this. An atom is the smallest particle. An atom is the smallest particle of an element that may or may not be exist independently. Are you getting my point? Atom, for example, hydrogen. This is the element. The atom of a hydrogen maybe we get independently or may not be we get independently in the nature, with having their all properties with them. Right? Next point we can see here. The atom are the very smallest, very small in size, and the smaller than anything we can imagine or compare with the atoms or the other. It means there are the very minute. We can't compare the size of an atom with some other elements or some other substances that are very small. We can say that we can't see with our naked eyes. Until that we say that there are the very small in the size. What is the size of atoms here? If we see, the atomic radius is measured in the nanometer, the radius of the atom. For example, look here, this is the circle, or we can see that this is the atom, and this is the center point of this atom, right? We can see the distance between the midpoint of the atom to the circumference of that atom is known as the radius. The radius is measured in the nanometer. Nanometer. Here, 1 nanometer is equal to 10 raised to minus 9 meters, or 1 meter is equal to 10 raised to 9 nanometers. Right? For example, here, the radius of an atom of a hydrogen having 10 raised to minus 10 meter of the radius. Radius of water, if we see the radius of the molecule of the water, if we see the radius of the molecule of the water, that is the 10 raised to minus 9 meter. Are you getting my point? This is the very easy. You can note down these points. You can get very clear idea about the what is the element, who proposed about the atom, that is the Dalton is the fellow who proposed the Dalton's atomic theory, right? Next, symbols of atoms of a different element. We use the different symbols for the different elements here. Let us see. The symbol, right? The symbol of elements are represented by the letter. I mean, the symbols we use to represent the element, that are nothing but the alphabets. The symbols of the some elements are represented by the one letter, and symbols of some elements are represented by the two letters. Some elements are represented by the one letter, and some other elements are represented by the two letters. One is the capital, another one is the lowercase letter. Before we just saw in the few minutes back here. Let us see what are that. How we have to write the symbols. What is the procedure to write the symbols of the element? If the symbol has only one letter, it should be written as the capital letter. If it is a only single letter to represent the element, then we have to write it in the capital. For example, you can see here nitrogen. We represent the nitrogen with the single letter, so we are going to write N as a capital. Oxygen, we use the single letter to represent the oxygen, so we write the O in the capital letter. We represent the potassium with the K, so only single letter, that we write the capital K to represent the potassium. Next, what is the condition for the next here? Let us see. If the symbol has two letters, if the symbol has the two letters, then the first letter should be written capital, and letter second is written in the small letter. For example, we see here the aluminium, we represent by the two letters, so we use A as a capital and L is a small. We use the two letters to represent the argon, so we use the capital letter A first and second one in the small letter. Barium represented by the two letter, so we use the B as a capital and A is the small letter. Look here, second one. Boron we represent only with the single letter B, so we write it as a B, capital B. If we see the bromine, we represent it by the two letters, one is the capital, another one is the small. Calcium, we use the capital C and a small a. Like this respectively, if there is a single letter to represent the element, we use only the single letter capital or the capital letter. If there is the two letters to represent the elements, we use the two letters, one is the capital, another one is the small letter of that element. I hope you people are getting clear idea about the element. Atoms. Just I am telling you about the atoms. Atom are the smallest particle present on the earth. Very smallest particle, it is the smallest particle, right? These are the atoms are present in the elements, or we can say it is the atoms are the part of respective elements of their own kind, right? Atoms are represent or the in the atoms having the same property as its elements has. And the Dalton, John Dalton is the scientist who proposed the theory of atomic, what we call the atomic theory. It means atomic theory related to the atoms. Okay, now we are studying about the element. Are you getting my point clearly? Let us see the further. What is the atomic mass? Atomic mass. Look here, since the atoms are very small in the size, the atoms are very small in the size, its mass is very small, and the extreme mass is very difficult to count, or the estimate the mass of atoms are very difficult. So the mass of an atom is compared with the mass of a standard atom. We are going to compare the mass of the atom to the standard atom. Mass of the standard atom, that is, let us see the next point. The atom which is considered as the standard atom for comparing the mass, this is the mass of other atoms is carbon 12. We use carbon 12 as a standard atom to compare the mass of the different atoms here. We use the carbon as a standard form. Carbon C12 is the standard form to compare the atomic mass of a different elements. Are you getting my point? Here, one atomic mass unit is represented by the U. It is the mass of 1/12 the mass of a carbon atoms, right? So we can see here the atomic mass of a different element is defined as the average mass of one atom. This is the atom here, it is hidden here. Atom of element compare with 1/12 of the mass of a carbon, that is carbon 12 atom here. Average mass of a atom, total average mass of a atom of a elements compared to, we are going to compare it to the 1/12 mass of the carbon. Here we can see that element hydrogen atomic mass is 1, carbon have atomic mass 12, nitrogen have atomic mass 14, oxygen have atomic mass 16, sodium has 23, and the magnesium has 24, or the aluminum have 27, sulfur have 32 atomic mass. Right? Are you getting my clear idea? Let us see the next point is the molecule. This is the last point we are going to discuss about the atom and the molecule. Molecule is the smallest particles. Remember that. Let me explain you here. Look here. A molecule is the smallest particle of element or compound which exist independently and show all the properties of the substances. Sorry, the electricity is gone here, so you can't see my face. Let us continue with this only. The molecule is the smallest particle. A molecule is the smallest particle of an element. Look here. First one is the atom. Second one is the molecule. Right? The molecule is the smallest particle present in the atom, an atom or in the compound which exist independently. It totally exists independently. We can see the molecules of the water in the form of vapors. We see the molecules of the carbon in the nature. We can see the molecules of the hydrogen in the nature. We can see the molecules of the helium in the nature. We can see them independently with having their own property which has the element or the compound has. Are you getting my point? Molecule of a hydrogen having the properties of the hydrogen. Helium molecules having the properties of a helium. If they find the independently in the nature. Next point. A molecule is a group of two or more elements. Another one point, molecule is the group of two or more elements that are held togetherly. By attractive force. For example, here you can see here hydrogen hold hydrogen very tightly. Oxygen hold the oxygen molecules very tightly, and nitrogen holds very tightly with another molecule of the nitrogen. Are you getting my point clearly? Here chlorine hold the chlorine molecules very tightly by the attractive force, by the attraction force. Atom of the same element or the different elements can join together to form the molecules. Atom of the same element or the atom of a different element, they can join each other to form the molecules here. For example, we can see here the molecule of a nitrogen, right? The molecule of a nitrogen hold the molecule of oxygen very tightly here to form the nitrogen oxide. Here the water molecules hold the hydrogen molecules to form the water molecules. Are you getting my point? Here nitrogen molecules hold the oxygen molecules, two oxygen molecules to form the nitrogen dioxide. Here one carbon molecule hold the two oxygen molecules by the attraction force to form the carbon dioxide. Are you getting my point clearly? Let us see the next point. Molecules of an atom. This is the last point. After that we are going to continue in the second section. Okay. The molecules of the element. The molecules of an element. The molecules of an element consist atoms of a same element. It consists the same element. And molecules of some elements contain only one atom and molecules of the some element contain two or more elements here. Are you getting my point? Molecules having the same atoms or the different atoms, or the molecules atoms contain the same type of elements or the more than elements. Okay. So today we are going to stop here. The remaining part of this atom and the molecules we are continuing in the next class. So thank you very much for the listening my class up to this. Sorry for this disturbance because of the heavy rain. Here there is no electricity. So we are going to continue it in the next class. Thank you. Thank you very much. And please subscribe to my channel.